Hey everyone, welcome back to yet again another Unit A video. This time it is Lesson 5, titled Particle Diagrams. So in the last video, which was on the longer end of things, we covered physical chemical properties and physical chemical changes. And so today we're going to cover things called particle diagrams, what they are, how to draw them. We've kind of alluded to this in previous videos, but here we'll start to kind of bring everything that we've talked about this unit so far together. This is a good way to kind of bring all the facts we've learned so far, put them together, and apply them. So here we have our flowchart of matter that we saw in the second video, I believe, and again in multiple videos. But particle diagrams are these pictures. So these pictures tell us something. It's a diagram of the particles, just as the name says. And depending on what's drawn and how they're drawn, they tell us different things. So a particle diagram is a picture that represents atoms, elements, compounds, mixtures, and even phases of matter. So you'll see there are different types of drawings. Color is a big factor in this, so we'll have some fun with coloring. And color is involved in this topic. So let's get into it. Before we move forward, let's just take a quick review of pure substances. Remember, pure substances, they cannot be broken down physically. Cannot be physically separated. So we can't use any of the separation techniques that we learned in that video to separate a pure substance. They have distinct properties. So H2O will always be water. You can't just change the H's or change the O's. Water will always behave as water. Again, cannot be separated by physical methods. And properties do not vary from one sample to another. So the water in my water bottle on my desk right now is the same water and acts the same as the water in your water bottle or the water in a water fountain. The properties of water do not change, or any compound or any pure substance for that matter. Elements, again, are made up of one type of atom, and we'll get into what an atom itself is made up of, but elements are made up of one type of atom. They cannot be broken down by physical or chemical means. Some examples are oxygen, nitrogen, and carbon, and literally anything on the periodic table of elements. Okay, so some elements we call are monoatomic, and mono means one, and atomic looks like the word atom. So monoatomic means there's one element by itself. There's only one atom. And so here we have some examples. We have sodium and chlorine. Do you see how these atoms are existing on their own? They're not hanging out with anybody. They're good on their own. That is monoatomic. Now, some elements are diatomic. So di means two. Again, atomic is talking about atoms. So you have two atoms. Now, a diatomic element is two atoms of the same thing coming together to form a stable molecule. You can kind of think of diatomic molecules as identical twins that can't go anywhere alone. So oxygen needs to travel with its twin. Nitrogen needs to travel with its twin. So it's two of the same element to the same atom, so it's still an element. They need to travel together. Those are diatomic elements. When we get into different things later on this year, we'll talk about why they're diatomic and which ones are. But for right now, diatomic means two of the same things coming together. Okay, so we have our examples O2 and N2. Now, atoms versus the term molecule. We kind of technically use them interchangeably, but they do have their own differences. Now, atom is generally referred to as individual pieces. So right now you have 6 copper atoms. We're talking about one thing. Now, a molecule generally has 2 or more atoms combined. So a molecule has 2 or more combined. But under the term molecule, it can either be a compound or an element. Now, a compound, you have 2 or more different elements And in an element, or a diatomic element, you have two of the same element. So a molecule just means you have more than one atom connected. Atom means one separate thing. If you have a compound, you have two or more different things connected chemically. If it's an element, it's two of the same things. Again, kind of tricky the wordings of things because people are so used to using them interchangeably, but they are technically different. Okay, so compounds, again, we've talked about this. They come together when two or more different elements combine chemically. Composition is identical. So again, just that water example, my water, your water, same thing. Properties are the same. You can't separate the water molecule with physical properties. You must need chemical methods. Another thing to point out that I don't think you've gotten to yet, properties of a compound are completely different than the properties of the individual elements that make them. And a perfect example is sodium chloride, or NaCl. Sodium is an explosive metal in water, and chlorine gas is highly, highly toxic. But you mix those two together, play with the electrons a little bit. NaCl is a great topping for food. So elements in a compound have different properties when they are separate versus when they are in a compound. Okay, so here we have some examples of compounds. We have water, carbon dioxide, ammonia. Hopefully you'll see two or more different types of elements. So again, we'll write that down, two or more different types of elements. Okay. Now, going into particle diagrams, let's do this. If we're going to draw a particle diagram for a monoatomic element, remember mono means one, atomic means atom, so we're going to draw one type of color. So what to draw or what to look for, one type of color, not connected to anything else. So you have a whole bunch of blue circles right here. If you have a diatomic element, remember di means two atoms, and we're talking about element, so you have to have the same color. You have one type of color connected to an identical circle. So now we have two different blue ones. If you see the same thing connected to itself, it is an element. It's one of those diatomic elements that cannot go anywhere without their partner. Okay, so these what to draw, what to look for tips are very, very helpful. Next is a compound. So a compound, remember, is two or more different elements combined. So you have two or more, what to look for, what to draw, two or more circles connected that are different colors. So we have blue, and now we have a green. When you introduce a new color that represents a different element, so you have two or more different elements, that is a compound. So there is a difference between this and that. If they're two connected that are the same, it is a diatomic element. If it is different colors, that is a compound. Now, what do we have represented by this particle diagram? Whenever you see a picture, you should try to label all the different pieces. So we have, this is an element, and if we want to be specific, this is a monoatomic element. This green is also a monoatomic element. And so we have a mixture of monoatomic elements. So again, when you have a particle diagram, look at each individual thing, label each different piece, and then you're able to figure it out. Next, we have this. So here we have two of these circles connected together, but they are the same color. So this is a diatomic element. And same over here. Yes, there are two circles, but they are the same color. So that is a diatomic element. And so we have a mixture of diatomic Sometimes you'll see diatomic, sometimes you won't. You'll just see an element. But again, we know it's an element because it's two things that are the same identical things connected to each other. Okay, here we have a yellow circle all by itself. This is an element. It is a monoatomic element. I'm going to write Me for that. Here we have another monoatomic element because it's by itself. Here we have a diatomic element because it's two of the same things connected. So we have a mixture of elements. Here we have a few different pieces. This one right here, you have 2 green and 1 yellow. So if you have 2 or more different colors, that is a compound. Same thing with here, 2 or more different colors, that is a compound. And so we have a mixture of compounds. Here we have a bunch of stuff, so let's look at each individual piece. Here, a single color by itself is a monoatomic element. Here we have 2 of the same colors, that is a diatomic element. Here is another diatomic element because it's 2 of the reds connected. Here is a compound because you have 2 or more different colors. And here is another compound because you have 2 or more different colors. So we have a mixture of elements and compounds. Okay, so these are kind of as complicated as it gets. Helpful tip, label every single different thing that you see as either an element or a compound. If you wanted to get specific as monoatomic versus diatomic elements, you totally can. But labeling is your best friend. So just quickly, we covered this in, I think, our first video with what matter actually is. Solids. If we're drawing a particle diagram of a solid, generally they're individual things. Their particles are very, very close together. Remember, solids have definite shape and volume. A group of connected circles that do not take the form of their container. A liquid. Remember, you have indefinite shape but a definite volume. So the particles will be kind of towards the bottom of the container. Just think about what a cup of water looks like. Water is on the bottom of the cup. It doesn't, it's not everywhere, it's just on the bottom. And they're spread out a little bit so they can, move around. And then particle diagram of a gas. Remember, indefinite shape, indefinite volume. Circles go everywhere. They should be spread out as far as you can make them, all over the square that is a gas. So, on that note, that is it for particle diagrams. We'll continue practicing with this in class, coloring stuff and identifying stuff. But until then, or heads up till the next video, we will cover in more detail density, the formula calculations, and all that good stuff. But on that note, have a wonderful